All right, so welcome back to this part two. And if you have not watched part one, click on this link so that you can go straight to part one, where we discussed question 1 to 5. Now we are picking from question number 6 so that we can be able to see the rest of the question that was clear. The diagram shows a full-scale drawing of an object or with thin lens and the image eye of the object. So candidates were asked to label or identify candidates were told to identify Z, and Z is this line that we are having here, so which means student was supposed to say that is a principal axis. So students were to identify what line that represents. Then we have the focal length, we have the optical center, we have the principal focus. We're going to see and look into that. Determine the focal length. So the only diagram that was given was this particular point, this one here, and also this image. Those were the two parts that were given to candidates in this question. So what I did, I decided and I constructed the image. Usually the first line that you're going to construct whenever you're dealing with array diagrams of thin lenses is joining a straight line from the top of the object. And you can see here from the top of the object, you draw a line that is parallel to the principal axis, a line that is parallel to the principal axis. Then the moment that line meets the lens, you are going to pass it, and that line should go to the top of the image. The second line we're going to have also is a line that runs from the top of the object through the optical center of the lens. And whenever the two lines are going to meet here, this is basically where the image is going to be formed. But also you need to note that the point where this line from the lens is going to cross the principal axis is going to be our principal focus. So if you are asked to determine the focal length, it means you are going to measure using your ruler the distance between the center of the lens, and that is going to give us a focal length. Yeah, so you are going to measure that using a ruler on your end so that you can be able to mention that. State two characteristics of the image. We're told the image is inverted. Yeah. So what are other characteristics? So you can see the image, yes, is inverted, but also the image is real because it's formed by real rays. We have not imagined rays here. We have just drawn real rays, and this gives us a real object. And also the object size, if you can measure this, you will realize, or even by visualization, you realize that the object size and the image size are the same. They are equal. So the characteristics, we're going to say same size as object and also real because it's formed by real rays. But if we were talking about an imaginary ray, then we shall have imaginary image. So you can see like here, if you draw a ray that is parallel to the principal axis and it will pass through the principal focus, and another ray from the top of the object through the optical center of the lens, and then it means that these rays, if you look at them clearly, they are not going to meet to the front anywhere here, anytime. They're not going to meet to the front. So you're going to extrapolate the lines backwards, and then you're going to realize that the two extrapolated lines, they're going to meet somewhere here. Then that's where the visual image is going to be. Yeah. So this is the visual image, but it's magnified. Those are the characteristics. And also it's behind the objects and the image are on the same side of the lens. So some of the ideas that you need to understand when you are asked a question like that is characteristics and also how to sketch these rays. Let's look at the next question. The next question is a question to do with electricity. In question number 7, candidates were tested the question on electricity, and then you can see here they were given 2 identical cells so that they can be able to work out different question. The EMF of the cells is 1.9.0. Now determine the EMF of one cell. Because there were two, then EMF of one cell will be 9.0 divided by 2, and that's going to be 4.5, and the unit for EMF is volts. Something I need also to mention here, you need to know how to define EMF. EMF is the amount of work done to move a unit charge around a complete circuit, while potential difference is the amount of work done to move a unit charge between 2 points in a circuit. That's a very common question that is basically usually asked, and candidates of Igcse 0625, they need to know, they must be able to answer such kind of questions. Also, you can be asked to give differences between EMF and potential difference, of which EMF is difference is that one is to move a unit work done to move a unit charge across a complete circuit, and the potential difference work done to move a unit charge between 2 points. So that is the difference. But similarities, you can say both of them are measured in volts, both of them is work per unit charge, and also we can say both of them are measured in volts. So that one has to sink down so that you can be able to answer some of the questions here. And then let's look at part C. Part C, part B, where did it go? Where did part B go? Okay, part C, I'll check out what was which question was asked here. I have to check which question was part B so that I can mention to you, you'll be aware about it. Yeah, so that you can realize part B, what question was it? Yeah, so part B, okay, so what I do, I'll just take a screenshot and paste it there so that you can have a look at it. Yeah, so part B was asking this. Complete the sentences to define electric current. Complete the sentences to define electric current. Complete the sentences to define electric current. That was the question that was being asked. Yeah, complete the sentence to define the following. So we can be able to say current is a flow of charge per unit time. Current is a flow of charge per unit time. So that is the question, that electric current is the amount of charge flowing per unit time. That is part B. Yeah, so part B. I believe it's clear now. You've understood what was part B. Then part C. Now we are told that the resistance of the fixed resistor is 480. The resistance of the fixed resistor is 480. Calculate the resistance of the thermistor. So the first thing you are supposed to do in such a question is that you are supposed to work out the total resistance in the circuit. And how are you going to work out total resistance? From Ohm's law, we can say that total resistance is total voltage over total current. So we were told here the current in the ammeter was 4.6 milliamperes. So which means that 4.6 milliamperes is the same as 4.6 times 10 raised to power negative 3 amperes. Milliamperes, you convert it to amperes. And then the total voltage was 9. So we can be able to say 9 divided by 4.6 times 10 power 3. We shall get 1957 ohms as the total resistance in the circuit. Number 2, you come and look at how are they connected. They are in series. So that means that if this one here is 480, we can say let this be X. Then X times 480 must give us the total resistance that we have gotten here. And if you work it out, you are going to get your answer being equals to 1477 ohms. 1477 ohms. So basically that's what you are supposed to do in that question. Next, part D, candidates were supposed to understand how does temperature affect the how does temperature, change in temperature, affect the resistance of a thermistor. So remember that when temperature increases, resistance decreases for a thermistor. If temperature decreases, for instance, this thermistor was placed in ice, therefore it means that temperature decreased, then it means resistance increased. And if resistance of a circuit increase, current is going to be decreasing. So meaning that if resistance increased in the circuit, current decrease, and that means that we are going to say here the voltmeter reading, the ammeter reading is going to decrease, but the voltmeter reading is going to stay the same. The voltmeter reading is going to stay the same. In question number 8, we are going to talk about transformers. You need to understand the concept of transformers. Remember, we have two types of transformers: step-up transformer and step-down transformer. A step-up transformer increases voltage, and it has more turns in the secondary coil than the primary coil. But for a step-down transformer, you can see here, this is a step-down transformer which is used to reduce voltage and more turns. This is this one here, we can call it secondary coil or turns, and this is primary turns or primary coil. So in the primary coil we have more turns for a step-down transformer, and in the secondary coil we have less turns. And this part here is called soft iron. This is soft iron. Yeah, but the turns are made of copper, because the copper is a good conductor. Iron is used here because it is a soft magnetic material. It can be easily magnetized and demagnetized. So if you are asked a question like this, you need to remember the formula: voltage in the primary coil or voltage in the secondary coil is equal to number of turns in the primary coil over number of turns in the secondary coil, so that you can be able to substitute and get your answer there. Now, Roman 2, we are supposed to use the relationship power in equals to power output because of the 100% efficiency. Then if power in is going to be the voltage in the primary coil times the current in the primary coil, should be equals to the voltage in the secondary coil over the times the current in the secondary coil. But since we are told that this is connected to the secondary coil, meaning that the cathode is connected to the secondary coil, and if you multiply current and voltage, basically it's going to give you power. Yeah, this is power output, and that power output should be this one that we have here. So we are going to say that current in the primary coil times voltage in the primary coil should be equal to the power output, which is 2.2. Then since we are working out the current in the primary coil, we shall say current is equal to the power output in the secondary coil divided by the voltage input that we had gotten from the previous question. So basically in this question, what we are doing, we are saying current in primary coil times the voltage in the primary coil, which we had gotten 33,163, should be equal to the current in the secondary coil times the voltage in the secondary coil. But current times voltage is giving the power, and the power output in the secondary coil is 2.2 times 1,000. Because we are having kilowatt, then we divide by 33,163 over 33,163. That's exactly what I did in this particular question. So that we can be able to get our answer at 0.0666. Yeah. Remember the purpose of step-up transformers, step-down transformers is to ensure that we can be able to transmit power at high voltage but low current. Power loss is given by current squared times the resistance. Candidates were supposed to answer how step-up transformer reduces power losses. Remember, step-up transformer increases voltage, and when voltage is increased, current decreases. One of my candidates was asking me how does that happen? Remember, power of electricity is equals to IV, right? When electricity is generated, it has a given power, right, which is IV. So when you use a transformer, what is affected or what's changed is only the voltage, okay? So voltage, the only that is affected, meaning it's increased, but the power of that current that is going to be transmitted stays the same. So meaning if the voltage is increased and the power has to stay the same, then current must decrease so that power can remain the same. I don't know whether you are getting me. When electricity is generated, it has some value of power. So if you increase voltage, power has to remain the same, then current must reduce. All right? Now, explain how the step-up transformer reduces power losses during electrical transmission. We can say it reduces the current so that power is transmitted at low current. It reduces the current because when voltage is doubled or increased, current decreases so that this electricity is transmitted at a low current. And since power loss is equal to I squared R, yeah. The figure shows a beam of alpha particles and gamma radiations as they enter an electric field. Remember, electric fields in this case now, they will be pointing from the positive to the negative plate like that. Those are the electric fields. Since the alpha particles are positively charged, so they are going to be attracted to the negative plate. But gamma radiations, they don't have any charge, so they are going to pass through the field undeviated. But also, if we were having beta particles, which are electrons, they will be attracted to the positive plate. Yeah, so that's something also you need to understand. So alpha particles will be experiencing a downward force because they'll be attracted towards the negative plates because they are positively charged. Student places a sheet of paper in the path of beam, yeah, and then alpha particles, what will happen to them? They are going to be stopped by paper because alpha particles cannot penetrate paper. They can be stopped by paper. Gamma radiation, they are going to pass undeviated through the paper because alpha particles cannot penetrate paper. Beta particles can penetrate paper, can be stopped by aluminum, but gamma radiation, they can penetrate through all those, but can be stopped by concrete or thick wall of lead. Yeah, so the beam of alpha and beta radiations is replaced with the beam of beta particles. State and explain the part of beta particles in the electric field. Use the idea about electrostatic force. And remember, beta particles are negatively charged, right? They are fast moving electrons. So it means they're going to be attracted. They are going to be attracted towards the upper part of the plate. They are negatively charged, so they'll be attracted towards the positive plate. So they are going to experience electrostatic forces and they are going to be moving upward. Beta particles are negatively charged, and that is the reason. In question number 10, space physics, candidates were supposed to complete these sentences. When the star expands, they run out of hydrogen, and the red giants form planetary nebulas, and the state what at the center of a planetary nebula we have white dwarfs. Yeah, so a planetary nebula emit blue lights and the red light are two specific wavelengths, that is 5.0 times 10 raised to power -7 and 6.6 times 10 raised to power -7. Explain why the light with this wavelength is blue. A blue wavelength, red shift is a longer wavelength, but blue shift as to what the shorter section, shorter wavelength. So that wave that has a shorter wavelength is blue, but those that have longer wavelength, they tend to be to the red section of the spectrum. Yeah. The speed of light in a vacuum is 3.0 times 10 raised to the power 8. Calculate the frequency of blue light. And blue light, we have said, is the one that has less wavelength. That's 5.0 times 10 raised to the power negative 7. Then we're going to use the wave equation here in order to work it out. And then it means that candidates were supposed to remember the wavelength is speed is equals to frequency times wavelength. Then if you can rearrange this equation, you'll get V over lambda. And if you work it out, you're going to get 6 times 10 raised to the power 14 as the frequency of this type of light. And then we have question number 11. Then we are supposed to talk about orbital speed is given by V is equals to 2 pi r. In this section, you need to understand different types of orbits. You need to understand a type orbit where the sun is gravitated toward one end, like this, that we are having at this particular point is basically what we call the orbit of a comet. This is the orbit of a comet. This is the orbit of the comet, orbit of the comet, and we have our comet at this given point enjoying and having good time moving around. And you need to realize that the speed of the comet will keep on varying depending on its position. When it's farthest, it's going to be moving at very slow, and when it's very close to the sun, it's going to experience a very strong gravitational force, so it's going to move at a very high speed at this particular region. Yeah, it's moving very fast when it's very close to the sun. And at this point, having high kinetic energy. Here is having low kinetic energy but high potential energy, and we are having the law of conservation of energy also when objects, celestial objects, are moving in their orbits. All right. And then we are talking about the orbit of planets. They are quite circular. This one is much elongated, very elliptical, but orbit of planets are a bit elliptical, but not as much elliptical as that of a comet. Then we have, then we are talking about a planet at this given point, then if this is our beautiful planet, then we shall have also another object that's orbiting around a planet, which is called a satellite. Maybe we can talk of the moon. The moon has a circular orbit. It orbits around a planet. So you need to understand differences between orbit of a comet, orbit of a planet, and orbit of the moon or a satellite, so that whenever you're asked about differences and similarities, you can mention. For instance, if you're asked similarities between orbit of a comet and a planet, is that both of them, they orbit around the sun, but that of a comet is more stretched, more elongated. Differences between orbit of a moon and orbit of a planet is that the moon orbit around the sun. The moon orbit, that's an international crisis, guys. The moon orbit around the planet, and its orbit is circular, but the planet orbit around the sun and its orbit is elliptical. Yeah, so you need to understand that. So in this question here, student was supposed to identify what R mean. R is the radius of the orbit, and T is the time period. Time period is the time it takes an object to orbit around to make one complete cycle or one complete revolution. Then we have another part of the question that explains why the orbital speed is an average value. Remember, I mentioned that the object is not going to have a constant. Speed will keep varying depending on the position where it is. So that is why you realize that as this speed keeps on varying, then it means now the speed that we are going to have is actually an average speed. An average speed we shall be talking about. So that is what student was supposed to mention there. And there was also the last question that made most of the students cry in the exam. This question is about approximate light years. So the first thing that you need to understand before you do your exam is what we mean by a light year. A light year is distance traveled by light in 1 year. Okay? One light year is distance traveled by light in 1 year. But how do you get it? We know distance is equal to speed. Distance is equal to speed times time. Then if it means if we want to know what 1 light year is, we need to know the speed of light. We have said 1 light year is what? Is a distance traveled by light in 1 year. So meaning that we need to work out the distance traveled by light in 1 year. So we shall use the speed of light, which is 3 times 10 raised to power 8 times time in 1 year. How many days do we have in a year? 365 days. How many hours do we have in a day? We have 24 hours. Yeah. Then 1 hour has how many seconds? 3,600. Then if you multiply this value, let me check here. We shall say this is going to be 3 times 10 raised to power 8 times 365 times 24 hours times 3,600. If you work it out, you are going to get this being equivalent to 9.46 times 10 raised to power 15 meters. Yeah. All right. So but this question we are going to look at something else at years. This is a bit different, but I brought this to your attention so that anytime you're going to be asked this question, guys, you'll also tell me that you were able to get it. So this is 1 light year is equals to 9.46 times 10 to the power 15. That's, by the way, it was not part of this question. Saturn is 1.4 times 10 to the power 12 meters from the sun. That's the radius. Yeah. So we can be able to use that relation and work because orbital speed is v2 pi r over t, right? Now we can be able to use this formula to work out the period. Time period will be 2 pi r over the orbital speed, average orbital speed. But our average orbital speed for Saturn was given here. So we can be able to say that 2 pi times the radius, also radius is given here, this is our r, we can be able to get t. And if you work it out, you are going to get 2 pi times 1.4 times 10 to the power 12 over 9600, and that is going to give us 9.2 times 10 to the power 8 seconds. Convert that to earth years. We are going to say convert that to earth years. Converting to earth years. 1 earth year is equals to 3.15 times 10 raised to power 7. Okay, so which means that we can now take how many earth years are we going to have? How many earth years are we going to have here? Is the time period that we had gotten divided by 3.15 times 10 raised to power 7. And if you work out that value, you are going to get the value, which is 29, which is approximately this. And what's 1 earth year? What's 1 year? 1 year is basically 365 days. That's an year. So if you take 365 days times 24 hours in a day times 3,600, because in an hour we have that, we are going to get 1 earth year being equivalent to that value. Yeah. So that's 1 earth year. In 1 year, how many seconds do we have on earth? Is that? Then if you write this in standard form, basically you are going to get our value as 3.15 times 10 to the power 7. That's why I was having that value there, right? So that's exactly what you are supposed to do in that particular question. And if you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified, guys. And also consider sharing my channel to your friends so that we can be able to grow this channel together. see you in the next tutorial, and remember to come back to leave a comment how the exam went. For those who are going to do and to sit for this particular coming exam, guys, remember to revise well, prepare well, and I wish you all the best. I'll see you in the next tutorial.